to say we'll let this be the positive y going down. Okay, since everything's pointing down, so this is equal to normal force. We'll agree, right? Plus mass times gravitational acceleration. So those are your two force vectors. Does everybody see that? Does that make sense so far? Now, what's that equal to? Well, that's, since the radial acceleration is pointing toward the center, that's also in the plus direction. If we have down as being plus, so this is equal to mass times radial acceleration. Now, the radial acceleration is always given by you can look at it one of two ways. It's speed squared over the radius, or it's also equal to radius times the angular speed squared. Okay, in this case, either one of these. In this case, we want this one because the problem asks for the speed. So this is equal to mv squared over r. I think that's right. Yes. These terms here, I think I give you that on the problem. I'll give you that. Okay, so you don't have to remember the formulas for these.
It's not like this on the test.
It could be.
You can't tell me yes or no.
No, I cannot tell you yes or no. Because there's so many problems I could choose from. But you want to know how to work this one. Okay. Now, here's a question. So you see how I set this up?
Why is it mass times
Here? Because a force is a mass times acceleration. You have to have the mass. Remember, the force is a Newton. 1 Newton. 1 Newton is 1 kilogram meters per second squared. Got a mass into that in that force term, so it has to be a mass times.
Okay, so there we go.
Yeah, no, you have to have that in there. If it doesn't have the m, it's not a force. It's just an acceleration.
How did it go from how did it go from n plus mg equals mass and acceleration to the mv squared of r? Where does that m and v squared come from?
Here,
Yeah.
right here,
But where does the m?
here, because it's a force. Force is a mass times acceleration. So this is the radial force. That's basically the definition of force. Mass times acceleration. That's where the mass comes from. You have to have a mass to make a kilogram here. If you don't have a mass, you don't have a kilogram. So the centripetal acceleration is a v squared over r, but then you multiply by the mass to make that a force term. Remember that this is, look, you're summing the forces, you're not summing the accelerations. We're not doing this. We're summing the forces. Okay. Now, take a look at this problem. If the cart barely stays on and is about to fall off, what can we do with this expression? What equals to 0? So basically, if you're in the cart, which you would not want to be, I'm sure, okay, by the time you reach the top, you're going to feel weightless. Like you're going to fall, okay? But you don't. Because as you move past that top point, you start feeling a little bit of weight, okay? A little bit of your body weight to keep you in the cart. But right at the top, you feel weightless. Okay? So you're going to want to hold on to the cart until you stop. If that makes any sense. So basically, if the thing is almost going to fall off, then the normal force becomes zero right at that point. So normal force becomes zero, then what you have left is this right here. That sort of makes sense? Okay, so I think you can work it from now, from here on out. While you're doing that, you got a final equation? Okay. What cancels out here? Now solve it for B. It's canceled. Go back and look at that. Okay, I think most of you are tracking with this, so what this gives us, mg is equal to mv squared over r. Now notice that the mass cancels. Anticipated it might. So that gives us G equals V squared over R.
Okay, so what do we do if the mass times acceleration is like, there's three things equal to each other and I don't know. We have mg equals ma equals mv squared.
Right.
So what, like, I don't understand why they're all three equal to each other.
You don't understand why they don't.
I don't understand why they're all equal to each other and then you just use mg and not the mass.
They're equal to each other because of this. Because of Newton's second law. That says the sum of the forces is going to be equal to the mass times the acceleration. part here comes from the sum of the forces. Now, of course, I erased my body diagram. This here is the MA right there.
So why do we not use the MA? Like why
Okay,
can't we use the
So the MG is on the left side. He just replaced the AR, like the acceleration, the radial acceleration. That's the same thing as saying V squared over R. Like if you go back in our notes, that's the same thing. So he's just substituting that in because we're trying to find the speed. That's just another way of writing M times
Okay.
radial acceleration.
Okay.
That's just another way of writing it. So
You
it's
got
not three things equal to each other.
That makes more sense.
Yes.
That really makes more sense.
You have to
I get it now.
like
So it's really just
it's not really things equal.
We're not going to fall off.
I knew what you were asking, but I was like, I don't want to say it. You just have like, to me, I have to rewrite it. Like how he writes it confuses me. I have to rewrite it in my own way. Huh? Maybe. I need Charlie's help. Charlie's is more fun.
Yeah, that's correct. Okay, did we get some answers here? Okay. All right. So what you do is just multiply by R on both sides. I think most of you know what to do now. V squared is equal to GR. Take the square root of both sides. V is equal to square root of GR. That's what I was looking for right there. V is equal to square root of GR. Now understand something. This equation only applies if you're barely staying on the track. Okay? So it's only applies for that situation. If you're going faster, okay, let me go over here. So I want you to think about what's really going on. You go faster than square root of GR, then the normal force, what can you say about the normal force? It's going to be greater than 0. What does that mean? I'm sitting in the cart, and when I get to the top, I still feel a little bit of my body weight. Not much, maybe, but I still feel some of my body weight. So I don't feel like I'm going to fall down. Okay? Now, if you go slower than square root of GR, then what happens? You go slower than square root of GR, what's going to happen to you? Yeah. Basically, n is going to be 0 before you reach the top. Okay? So what will happen then is basically going too slow. That happens to you. Before you get to the top, then you start falling. You lose contact with the loop, and you start falling. Going too slow. The Hot Wheels. Going too slow, loop's too big, goes up, falls down. Okay? Welcome to the world of physics. Now, this problem. What is the speed if R is 10 meters? Just plug it in here. It's just plug and chug. What answer did we get? It's about 9.9 meters per second squared. No, per second, I'm sorry, not per second squared. Okay. Which is probably 20-something, close to 30 miles an hour, something like that. 25 miles an hour, we'll say. So you got to be going 25. Of course, 10 meters is over 30 feet, which means that the loop is over 60 feet high. You probably don't want to be on it, right?
So I got a question.
Yes, sir.
A question like this on the test. Out of all this work out that I've been into, what part are you looking for in the test?
Depends on the nature of the question. A question like this, this is a good question.
Right.
The
Not only
speed.
on the test like this, probably, so yeah.
Could be. And what I would give you, any sort of problem like this, I'm going to give you the expression for the radial acceleration, v squared over r, or if it applies, r omega squared. I won't tell you what these terms are. You've got to know v is the speed, r is the radius. But I'd give that to you. So you got this. What you got to come up with is basically this equation here. The sum of the forces is equal to mass times acceleration. That is a statement of Newton's second law.
So if the normal force would have been force V wouldn't be equal to square root of
Bingo.
V wouldn't.
No, it wouldn't be equal to this. Okay. As a matter of fact, it would be greater.
But on the test, is it going to be equal to 0?
If I ask a question exactly like this, that you infer, if I'm barely going to stay on the track, then that means the normal force is 0. I'm about ready to fall off. I don't have anything pushing against me because I'm falling off almost. Depends upon how the question is worded.
I thought you were going to get first one.
Do it over the weekend, work it a couple times. Okay, but then you've got other problems that you want to do to work as well. Come by and see me. I'll be here probably until about 3 o'clock. I think I'm going to leave a little earlier today.